the screen with you guys. Okay, my screen is visible. Okay. Uh,
Yes.
so basically, we'll create a new folder for today, day 2, and we'll create a new notebook as day 2. So our today task is to just go through Numpy, Pandas and Matplotlib and learn how can we use them in astronomy data analysis. So this is also a fundamental lecture to make our fundamentals of Python clear so that we can use in the real astronomical data sets. We will in the next lecture we will be getting hands on to astronomical data set, and we will be using everything we have learned so far in the first and this lecture. So now let's start with Numpy. So first of all, Numpy is an external library for Python, which is not initially included in Python. So a Python library is kind of a package in which there is a bunch of functions all together to make your code more small and faster. Let's suppose you have to create a function to calculate the redshift. Then you have to write everything from the formula and all that stuff. What if you create a function for redshift and just call the function every time rather writing again and again the same formula? Because there are some standard formulas in statistics, astronomy, which is not altered at some point of time. So similarly, the packages work like this. It create a journal kind of functions which can be used by calling in shortcut rather writing the whole big code. Similarly, Numpy stands for numerical Python. I'll write here numerical Python, and it helps us to do some numerical stuff. Okay, so it is very much used in astronomy. Okay, so first of all, there is some things we need to understand, that is Python list and Numpy arrays. Okay, so there is a difference between Python list and Numpy array. However, they all both feel same, but Numpy arrays are more advanced version of them. Okay, so I'll show you how. Let's say L is the list variable, and this is the way you can create a list from 0 to 9. So when I run this and print L here also, it will create a list from 0 to 9. So yesterday we used the range function. So here you can use that thing, and you can just write list here to create a list. Okay, so now I'll create a Numpy array. Okay, so before that I want to show you, I just skipped the part, how to install Numpy. There are two things: either just write this install Numpy and run. However, it's already installed, so it will say requirement already certified. So it's satisfied, and I'll just write here the way to install Numpy. So I'll make it bold. Okay, so I'll delete it from here. So the another option to install packages is go to the home web page, and you will see here terminal, and on terminal you have to just write pip install Numpy without that exclamation mark. If you are working on in the cell, then you have to include that exclamation mark. Okay, so now I will write a Numpy array. Okay, I'll write an array. So this was the Python list. Okay, and now I will write an array. So I'll do one thing. So to import a package, we have to use import the package name as AR. As AR means a shortcut. Rather writing arrays again and again, you can just write AR. So import is used to call the package or library, and used as is used for short names. Okay, so what I will do now is I'll create another list first. Okay, let's say L2, and I'll create a new list with the range of 11, let's say. Now I'll create an array. So AR dot array, I have called this AR from this library, and this is the function in the library which is also named as array itself. So this array and this array is different. This dot array is a function name, like def add bracket. It's a add name, kind of a function name, but this is a library name, a package name. Okay, so these both are different, however they have named them both the same. Okay, so what I will do is I will write D here, I'll show you why, and L2. So what this will help us to convert the list into an array. Okay, so this is a function to convert a list into an array. This is a syntax, but what is D here? The D is that the output must be a decimal value. Okay, so I'll write here that D stands for decimal output. Okay, so I have run this cell and I'll just go with the A. You see it's now showing array and data type D, and these all are in the decimal form or a float form. Okay, so this is the difference, and you can also do one more thing. I'll import Numpy now. So how we have to import Numpy? Import Numpy as NP. So to write Numpy we have used NP, a shortcut. Okay, so NP dot arrays, okay, array, and then let's say we just give it a random list 1 2 3 3 4, and we have defined the data type as float 32. I'll show you how what I have done actually. So basically I have given him a list and it has converted that into an array, and the data type is float 32. Now what is float 32 in specific? So there are different data types: integer 8 bits, integer 16 bits, integer 32 bits, integer 64 bits, and similarly we have float 16 bits, float 32 bits, and float 64 bits. So these are different data types. So float 16 bit is faster, but it remember less data. Float 32 is medium level slow, but contain more data, and float 64 focus on more storage and less speed. Okay, and similarly we also have complex data types, complex 64 and complex 128, even if we have to do a complex mathematics in which we have to use iota and all that stuff. Okay, so there are different data types. So this is the meaning of float 32. Okay, this float means the data type and 32 is the bit, okay, which define the function of this float. Okay, now let's use a very useful function. I have told you to create a matrix out of the list, right, yesterday. So let's create a matrix. Let's say a matrix of 3 cross 5, and how we will create that now. So we will create a matrix not in the Python list but as our arrays. Okay, how we will do that? Numpy dot array, and now brackets, and in a square bracket we have to give it a range. In the range I will not define 1 to something. What I will do is I will create kind of a loop. I will write that the first word is I, element I, and till it have to go to I plus 5. I plus 5. Oh, I plus 5. Okay, so it will start from I, then it will go to I plus 5, but not write the I plus 5 letter, the element. Let's suppose I is equals to 1, then it will go from 1, 2, 3, 4, 5. I plus 1 is 6, but it will not include the letter 6, the number 6. Now for I in, now we have to define from where, 2, 4, 6. Now you have to understand what I have done now. So first I have defined a range. Range is, okay, just a second. Range is from I to I plus 5 excluding I plus 5. I are starting from, I is starting from 2, 4 and 6. Basically these are the starting values of 3 cross 5 matrix. So these are the starting numbers of first row, second row and third row. That is, these are starting numbers for first, second and third row of this matrix. Okay, so we can even increase the columns by increasing this number. Since I have defined till 5, it will create a 5 column matrix, and I have defined it the 3 numbers, so it will be a 3 row matrix. When I will run this, you will see we have a very good output. The rows are starting from 2, 4, 6, and then 2 plus 1 3, 3 plus 1 4, 4 plus 1 5 and 5 plus 1 6. But 2 plus 5 is actually 7, so it will exclude the 7th letter, 7th number, and before that it will include all the things. Okay, so this is how you can create a matrix. So there is a very useful feature. Oh sorry, okay, it was as it is. There is a very useful function, very useful, used in a lot in astronomy. So it's called linspace. So this is very important, you have to remember. It's just very easy to use. You have to just write and p dot linspace, and then you have to define some kind of numbers to it, the range of the number. Let's say we want number starting from 1 till 2 with 7 points. Like it's like it will give 7 values evenly distributed between 1 to 2. So you see we have 1, 2, 3, 4, 5, 6, 7 values from 1 to 2. Similarly, you can give any number, any range, any distribution number. Okay, so this is very useful. We will be using this a lot. Okay, so there is one more way to create a 3 cross 3 matrices when we are dealing with a box matrix, basically a square matrix. So there is a shortcut, np.array, np.random. So if we want a specific numbers to be inside our matrix, we have to use these type of loops and functions, complex functions. But if we want some random numbers inside our this kind of matrix, we can use this thing random dot random. It's twice. Okay, so it will be like 3 cross 3 matrix. So these are double brackets. Remember, when I click this, it will just generate random values for 3 cross 3 matrix, and when I'll rerun this, every time the value will be changed because it's just randomly printing 3 cross 3 matrix values. Okay, let's say we have to create a random numbers, like we have to give it a range that these numbers which are now random must stay random but in a specific range. So how we will be doing that? There are some mistakes that people do that we don't have to do. Is we apply random dot random again and write a range first, let's say 5 to 6, which will be not including 6 as I told you, then comma 3 cross 3 matrix. When I run this, it will give me the error. Why? Because our range is an integer and we have to define it. Okay, so I will keep this error like this here so that you can remember this. So before this random, you have to delete the last 2 letters and just type int, and now you will see that your range is from 2, 3, 4 and 5, not 6. Okay, so this is how you can create a matrix. So how can we index a matrix? Yesterday we learned we can use slicing, indexing for list, but how can we use indexing on arrays? So let's say we have a list that we will convert into an array. So the list is in the range. A range can be now anything starting from, let's say, 21 to 30, and so it's the starting point, it's the ending point. Okay, then let's say array 1 is equals to ar dot array, and everything must be integer. So for integer you have to write I, and for the decimal you have to write d here, and which list we have to convert is L3. And then I will print I1. So we have the array in the form of integers now, you can see till 29 starting from 21, and now we will do indexing of an array. So now it's very similar, it's same. Okay, so you have to just write the array name, and then you have to write the bracket, and then you have to just give it an index, and you will see it will show 21. Similarly, you can go with the negative values, a1 minus 1, it will show the last value. Okay, so this you can play around. Now let's say how to index a matrix. Matrix contain different rows. This is just a row matrix, this is just an horizontal matrix, we can say like this. But what if there is more than 0 rows or columns? Okay, so let's create a matrix first. Let's say a2 is equals to numpy random dot rand int, then we will define a range from 5 to 100, let's say, and again let's say 3 to cross 3 matrix. So these numbers will be different for you guys because it's just a random integers. So I'll print a2 first. So this is my matrix. What I will do is, so in maths, in basic maths, all of you guys know, you are mathematics and physics students. So the first term is defined as aij, or a general term is defined as aij, and the place value for the first term will be a11, where I is the row and j is the column. So for indexing we will be using place values, that is Aij, where I is rows and j is column. So let's say I have to get first of all this number. Okay, so you must remember that in mathematics our first element is a11, but in Python it's a00. Okay, so the Python counting starts from 0, not 1. So we have to define it like this: a2 and then again this brackets and 0 comma 0. So this is basically a2 I comma j, but first value in Python is never indexed at 1 but 0. Okay, so when I will run this program, you see it shows me the 52 value. Similarly, if I can play around this thing, I get the it's like 1012 2 comma 012. Let's say 2 comma 2, it will show the last value. So initially we can see that it's 3 comma 3, but it's 2 comma 2 in Python. So it's actually n minus 1 kind of thing. Okay, so you can play around this. It's useful actually, because our fits file are usually in the form of tables, so they can be in matrices form. The tables can be of different columns and rows, so we have to deal it with like this. Okay, so yeah, so what we can do more, so similarly you can do slicing. Okay, so similarly you can fetch slicing thing. I'll show you one of the example. So since we have already done slicing and it's same as slicing in list, I'll show you 1 or 2 examples with them. So let's say let's create a new array with numpy dot array. From let's say 0 to 10. Okay, a3. Wait a second, what's the error here? Numpy dot why I have written arrays here? So we have to write range here. So in Python, in Numpy, this will also give an error, because in Numpy it's called a range, not range. Okay, so it will give an error. Okay, so it says module Numpy has no attribute range. So we have to click a in front of range and it will work. Okay, so these are different techniques to actually print arrays. Okay, so we can use range. First give it a range in the list and then convert that list into arrays, or directly give it a range. A range means array range. Okay, so directly it will print an array. So these are different methods you can create an array. Okay, so let's say I have to get the first 5 values till 4. So how will I do? The same method. Give me the first 5 values without skipping and all that stuff. It will be start, stop, skip, same. Okay, same method. Okay, so you can play around this. You can use negative values and all that stuff. Okay, but the problem statement I have given are way different what we are doing. So try to actually make them solved, because that are the main things from where you will learn. Okay, the problems you will practice, because they are actually a kind of application of astronomy for in physics in Python. So these are some problem statement that you must work upon. So now we'll move forward. So this is all about NumPy till now. However, there are some things like numpy.py. Okay, so it prints constants, so it will automatically print the value of pi. However, we will work in this manner when we are dealing with the formulas that contain pi, square root and all that stuff, so we will learn at that time. Okay, so now we will start with pandas. So pandas deal with the CSV files. So sometimes our data is in the form of text file, CSV file or an Excel file. Okay, so we have to deal with that type of data. We sometimes have to clean the data. There are some null quantities which we have to remove from our data, so we have to use pandas for that. Okay, so I'll just create a markdown here. There is something called CSV to create a CSV file. So to work upon, we need a CSV file. Okay, so I'll create just a mock CSV file of galaxies and their redshift. So I'll just create a random redshift data and galaxy data that are in my mind. So to create a CSV file, how we will do is data is equals to square bracket, then press enter, and for each row we have to again print a square bracket, then normal comma, and in this square bracket we have to write the first and the second column. So first column will be of galaxy, and after galaxies there will be redshift. Okay, so similarly after that, let's say we have M31 galaxy, so we have to write all these things in the form of strings. So let's say even if it's a decimal quantity, we have to write it in a string to store it. So let's say its value is 0.002. so I have some data, so I'll just use that data with me. So these are the real values, I guess, near to the real values. So 0.0092. so just I forget the put commas here, so remember you must put commas, otherwise it will give us syntax error. So I'll write let's say okay, NGC 7331, and I'll keep the value as null. So I will keep the value null. So what I will do is I'll keep one more null value, empty row. Okay, and now I'll create a one more value, let's say NGC 5907. Actually we can grab this data originally from SDSS, but right now it will make the things more complex, so we will just create our own data for now, but in future lectures we will grab our own data, real data. Okay, so I have created a very small CSV file now. So now we have to convert this data in a CSV file first, and then we will open this. So for creating a CSV file, we have to just write with open, then brackets, and then there is commas, sorry, the inverted commas, and then galaxies.csv file. So this is basically the name of the data file, and then mode will be is equals to write mode, so that we can write on that CSV file in future. There are also reading mode, and there is also reading binary mode, and there is also writing binary modes. So what is reading mode? Reading mode only allow to read the data but not to edit it. Writing mode is writing the data. RB mode is reading and the data will not be in the format like this, it will be in the binary format, and writing will be editing the binary format file. Okay, so right now we will work with the writing mode, and yeah, we'll create a new line. For new line we'll enter this blank thing here and as file. So this is the command line you have to write. So as we begin, as we go further in our course, we will have these types of long line of commands. Okay, so let's say writer is our variable, or writer is okay, and now we have to write CSV. We have to call this CSV thing here. CSV is always already a small file, a small module, so it is not used, not necessary to use as here. However, you can use it. Dot writer. So this writer is different. This is the variable name, so I'll just make it WR. Okay, so this writer is a function inside CSV. And file, so file is actually this file. You can actually write as X, but then you have to convert here as X, you have to change here X. So file is okay, seems good. Okay, so writer dot write rows, this is also a function. Okay, then data. So in the rows you have to add this data. When I will run this, okay, so it has run but nothing showed up. We will go to this home page and we'll refresh this. You see we have a galaxy.csv. When I open this galaxy.csv, you will see that I have these 5 rows with these data and 1 empty line and 1 empty redshift data. Okay, so basically the new line was used to give the first number to these values. Okay, so these otherwise it have given the index 1 2 3 from the galaxies, so we have defined it like that. Okay, so this is the thing here. Now we will import pandas. So to download pandas we have to use pip install pandas. So to uninstall pandas also you have to do pip uninstall panda. Okay, so these are some functions. So either you can do from directly from the terminal or this, oh sorry, what happened? Yeah, okay, so either you can use this terminal or you can just use this terminal here. Okay, or just use this cell. So when I'll shift enter, it will say I've already installed. So I'll import pandas as PD. So first of all I'll take the doubts if you have any. So there was some person. What is the difference between AR arrays and Numpy arrays? So basically AR arrays is a different module, Numpy arrays are different module, but their task is same. So Numpy is a different package, AR is a different package. Okay, you see I have import arrays as AR, right? So and at the same time in the different cell I have import numpys as NP. So basically they are different packages but their role is same. So as I told you, there are different ways to create arrays. So these are one of the ways. So you can create arrays from Python list by converting a list to as arrays using NumPy, or directly create an arrays using numpy.arrays, or you can use a different library which is arrays itself, like import arrays as AR and then AR.arrays and then further commands. So I hope this is clear till now, is it? Okay, so can you show the output of the pandas function once again? Yeah, I'm going to that. Okay, the tabular format. So you see I have just these random values, so you can create these type of by yourself and you can see. So what we will be doing is we will be deleting this kind of the null row, and we will be either making it 0 or an average value, or we will be also deleting this row as well. So these are the different type of methods. So is it clear? Should I begin with the pandas now? Yeah. I got the name error. Could you share, could you kindly copy the whole code and paste in the message? So it will help. Okay, so basically here you can see you have named it writer, but now when you are writing the data in the form of row, you are using wr, and wr is not defined anywhere. Either change the variable name to wr or just write the full writer variable name here. So basically why the last line is used, basically it is basically writing the file, and in the file it is actually writing the rows from that data. Okay, and for writing it as a file, we have defined it as a variable, and the variable name should be accurate. I hope this will fix your code. Okay, so I'll go back here. So you see I have written this variable's name. I'll just make a comment here that wr is a variable name which is defined to save the file as csv, and w dot writer rows is writing the rows from data in that csv file. Okay, so this is how it's working. I hope this is clear. Yeah. Now to import pandas, we have the command import pandas as pd. So you can either use p also. PD is a standard way, it is used by all. So I also have a kind of speed on writing PD rather p, so you can make it on based upon your convenience. Now once we have created the csv file, it's not necessary, it's actually a practice to tell you how you can create a csv file if you don't have one, or instead of this you can also use excel. Okay, so this is actually a python way to make a csv file. Now once we have a csv file, how to read it, okay, how to manipulate it. So let's say we have a data frame which is read underscore csv, and then the csv name which was galaxies.csv. So pd is actually calling the pandas, and read csv is a function from the pandas module, and in that function we have to just write the name, and df is actually a variable defined. When the df will be called, it will show us the values of df. Now if I call df dot head, what df dot head will do is it will just print the first 5 values. Okay, so will print first 5 values. Now I think we only have 1 2 3 4 5 values, so let me just add one more value, just a random value, let's say ngc 891, and let's say I'll just write some random number here, 0. Let it be again 0.025, I guess. Okay, so I'll rerun these things here. So when I will rerun this thing, you see it shows none value here and first 4 values, and the value which is ngc 891, it is not showed here because it will just print the first 5 values. Okay, so this is how the things work. So now let's manipulate our data. uh, it's very simple function which is used to drop the none values. So we have to import numpy here. So it is a function of numpy. Now since we have already imported numpy earlier, it is not necessary to write again and again now import numpy as np. Just for the convenience for this lecture I am writing it here. Otherwise in future we will just print whole of our libraries in just first cell, and then we will be just writing it as a code, just like this here. If I show you what I am trying to tell, so I just open one of some pipeline. So you see I have imported all of my libraries here on the top, and then I have written all the functions. Okay, so this is how the things work. We don't have to import in the middle of our code, okay, again and again, but for the sake of just learning right now I'll import this again. So we will call our df the data frame, and now there is a function called drop now. Okay, so it is basically drop none values. Okay, so basically it will drop the rows with the missing value, and in place is equals to true. So when I run this and I print df again, you see now it has dropped the values with the none. It has also dropped ngc 7331. It has also dropped the row number 3. Okay, so there is one more function which is known as drop duplicates. Now we will create a duplicate entry here. So let's say we have created the m33 twice. I'll rerun and save the code here. So what I will do is I don't want to run this again and again. I'll convert this as row. So row is something which is just a normal text but as in cell. Okay, so we have this now duplicate value here. When I drop the value, you see we still have the duplicate value. So the drop now function, this helps to drop the missing values and whole row. Okay, so this is how it works. And let's say we have now df dot drop underscore duplicates. Now in place we have to write in place is equals to true. Now if I print df again, you see that we don't have m33 again here, it's deleted now. Okay, so similarly there is a function in which we can fill the redshift value. Okay, so let's say we don't want to use this drop now function. Okay, but we want to fill this redshift value. Okay, so how to fill this? Let's say we want that the redshift value for ngc 733 must be a mean value of all these values. Okay, so how we will do that? It will be very simple. We will call the redshift column. So it works same like this, like indexing. So you can just writing index here, you can write the column name redshift, but it must be very precise in the case form. Okay, so dot fill now, this is the function to fill, and values, which value it has to fill will be is equals to numpy dot mean. So instead of writing a whole command that you have to, or either a loop that starting from I is equals to 0, you have to go till end and divided by 2, and you have to add I plus 1, I plus 2 and do addition and divided by the number of elements. You can just do numpy dot mean. Okay, then mean of what? Mean of df and then you have to write this thing whole again. So it will do the mean of these values, and again in place is equals to true. So you see here, this is something different. Okay, so it's giving a warning. So a value is trying to set a copy. It's not an error, it's a warning. A value is trying to be set on a copy of a data frame or a series to change the assignment using. Okay, so it says that this behavior which we are using, that is in place true, is being changed in the newer model of Pandas. I have an older model of Pandas, so I need to update it, but it's not a very big issue. So it's now like this. So when doing data frame columns, so you can also alter columns. So method values, just we write commas dot true. Now it's like curly brackets, columns, and then this colon and value comma in place true. So there are some syntax changes in the newer model, so that's not a big issue. So this will also work. If I just now there is an issue. It will actually work but not work because we don't have any missing values. We have already deleted the missing values. Okay, so let's say we rerun this command for now. Okay, so but I'll not run this command here. I will just directly go here, run this and print df. So you see it actually filled the none values with the mean values. So this is how it works. So below results are our output before running the dropna function. Okay, so we have not used dropna, otherwise it would have deleted the rows. So this is how you can work on this. Also you can rename a column. So this is one more feature. It's directly like df dot rename, then column, you have to just write columns s with s. So then curly bracket column, earlier column name which was redshift, and the new name which is, let's say, new redshift. Okay, so this is how we do that, and in place is equals to true. This is the syntax. Okay, so when I run this and when do this, you see we have a new column name which is a new redshift. Okay, so when I will refresh this thing here also, okay, so we have to actually save this. Okay, so we have to save all these things, otherwise it will be just stored in our this as a data frame, not in actual file. Okay, so how to do that? You have to just write a one single line df to underscore csv. Okay, so we have to convert the data frame into csv, and then we have to, like, we can write a clean galaxy data dot csv, and index is false. Why index is false, I'll show you. When I run this file and I refresh to the home page, you will see one more csv file, and index is equals to 0 is basically for not to writing 0 1 2 3 but 1 2 3 4 5 6 7. Okay, so here you can see it has given the mean values to these empty data set. Okay, so any doubt till here? So what is the in place function? So here it's actually a syntax. Right now I have also not explored that much a lot, so but right now I can't tell you why in plus exactly use, but it is a kind of syntax only for placing these things. But actually I have not explored that much for this particular function. This was actually syntax kind of thing, so I much focus on that other things. So yeah, so any more doubts? so that we can begin with another part, which is our Matplotlib. So any other doubt? I'm unable to install Pandas. Why? It's actually very simple. You can just go. So, what command are you writing? Are you using a cell or are you using a terminal? So, are you using a cell or a terminal? So, you are using terminal. What are you writing as a command? Are you writing pip install pandas or exclamation mark then pip install python or pandas? So, in terminal, you just have to write pip install pandas, not exclamation mark. No, this you don't have to write in terminal. This is only for the cell. For terminal, you have to just write pip install pandas. This will work. So for even downloading, you can just go for pip install pandas, Matplotlib, Numpy, Astropy, Gilamo. So this will actually install all of the things together. Okay, so you can do it. So for multiple library installation, you can just do it like this, like rather doing pip install pandas, pip install numpy, so you can just directly write the names. Okay, so we'll begin. Okay, so now we'll begin. So basically what I think is in place is actually used for indexing, just like you see here. I'm not sure about that. I'll search properly tomorrow. But what I have seen here is when we have in place is equals to true, and when we have dropped the files, it has not indexed it properly, like 0, 1, 2, and then directly 5. So it's actually not changing the index right now. Okay, but why not? Let's do once. So you see, I was right actually, I think so. Yeah, so you see, when I dropped the file and printed it here, so you see when in place is false, it's showing 0, 1, 2, 3, 4, 5, 6, something like that. Okay, but still I think there is an error here, because it's printing something different and this is printing something different. Okay, just leave this here for now. I'll search it properly and tell you by tomorrow, because when I'm doing the false, it's also giving me our CSV file as output. So I'll search this thing and I'll let you know. Okay, so this is how right now we can work with the Python basic pandas. So now let's shift to Matplotlib. Okay, so Matplotlib is basically for plotting our data, plotting and visualization. Okay, so I'll convert this as markdown. So Matplotlib is used when we have a CSV or a FITS file, and then we use it to plot to and visualize our data. So right now we have two options. We can directly jump to the Astropy thing and we can just plot the beautiful nebulas images and beautiful Russell diagrams or star diagrams, other diagrams, or we first plot the sine, tan or other values. Okay, I think plotting basic functions like y is equal to mx plus c or sine values, tan values, or all these values will be fine for now. because jumping directly into the complex part will create a problem. Okay, so now we will be doing a basic Matplotlib stuff today, and tomorrow we will be doing AstroPy stuff. Okay, we will be jumping into application of astronomy. But I will let you know the timings of tomorrow, because I have tomorrow 6 to 7 hour travel, so it might not be possible to take class tomorrow. Otherwise we will take a class in night timings, evening timings, late evening timings from 9 to 10, or otherwise we will shift the class to the next day. Okay, so there will be 1 day gap, so that's not an issue, we will cover it. Okay, so for downloading Matplotlib you can just write just a second, pip install Matplotlib, or this command is for cell, pip install Matplotlib. This command is for terminal. Okay, so I will not run this thing here, I'll just convert this as our row file. Okay, row cell. So now there is something difference, just like import numpy as np, we can't import matplotlib as plt or mat. We have to use matplotlib.pyplot as plt. Okay, so we have to write this pyplot extra in front of matplotlib to import this thing here. So now we will be using numpy. So you remember we today did a function in numpy that is called as linspace. So whenever we are plotting and we don't have a specific range of x's, we create our own x's. Okay, let's say we are doing Ohm's law plot and we don't know, the professor has not given us the range, and we don't know from the circuit diagram that what is the range, and we just have to make a plot. We know that the system will follow the Ohm's law and it will be the straight line or something. So we have to given it xy values, just a random value. For that we use a random numbers like 0 to 10, and will create it fit to the line. So similarly x-axis will be numpy.linspace, some random values from 0 to 10 with 10 units. Okay, so 10 unit gaps, with 100 even distributions, right? So for y will be writing as np.sin x, that simple. Okay, so we have defined our function as y is equals to numpy.sin x, and x-axis as numpy.linspace 0 to 10 with 100 distributions. So it's very simple, we are just defining a function. So you all know function is a machine which take some value and give us an output. What is a machine? Machine basically takes some input and gives some output. So it is also a machine which is taking x as an input and giving y as an output. So when there will be some like say numpy sin 0, numpy sin 1, numpy sin 2 and 100 of values, it will creating different values of y. Okay, now there is something called figure size. Okay, so we have to give a dimension for a figure. So how will we do that? We will call matplotlib now, matplotlib.figure, then this brackets figure size, fixed size, then is equals to, let's say we want a square figure of 6, 6, where first thing is like a comma b, where a is the width and b is the height. Okay, and then let's say we have to also plot grid, so it will plot grid. Then we have to give a label, like for example we are plotting vi graph, we write v on the y axis and I on current on the z axis, let's say. So we have to give them the labels simultaneously. So on the x axis it will be x, and plt dot y label will be sine of x, sine x. Okay, so also we have to give the title to the plot, it will be title, plt dot title. It's very simple, as the name suggests, it's working something like that only. Okay, so our first plot sine x. Okay, so now we have to just do plt dot plot, then x and y. Okay, so we have to just write x and y, that on the x axis there will be these x values and on the y axis it will be x values. And now you have to just write plt dot show, just this thing. And now we will run this command, and you see we have a very beautiful sine x plot. Okay, till 10 with 100 values. If I decrease the value to 10, you see the plot is not that much accurate, more will be the values. Similarly, like we do in the what was that, I just forgot the name, Markovnikov was different, I just forgot the name. It is a probabilistic method in which we just drop more values and it will give much accurate values in when we put more random values in it. Okay, so as we increase some distribution in it, it will give more better slope. Okay, so yeah, so how to save this figure? Okay, so when we are writing a research paper, especially in astronomy, when we are submitting an MNRS or APJ or ANA, we don't use a JPEG PNG file, we use a PDF of our plot. Why PDF? PDF actually creates an overall file as a concise and a small file, but with a high quality. Whereas if you will use high quality JPEG or PNG file, it will increase the file size with the increased quality, but when you will submit, there is a limit that your manuscript must be just 10 MBs. Okay, so it is possible that if you have more figures, your manuscript must be might go above 10 MBs, and you will be given advice from the editor that you have to compress your manuscript. And when you will compress that manuscript, it will compromise the figure quality. So after plot, but before plt.show, you just have to write plt.savefig, and then you have to write the file name, let's say sine x first plot .pdf, and you can just give it a DPI. DPI is basically the quality of the PDF. We usually use 1000 value, it's very good one. So as I go here and refresh this, you see this is a very high quality graph. Okay, so this can be used. So this is how you can create similar for the tan x. So I will not create for tan x, you have to just write tan x here. Similarly, you can do for cosine, so inverse trigonometric formulas and all that stuff. Okay, so this is how you can just do these things. You can create plots. Now what we will be doing is we will using plots in plots. Let's say we have this sine x, we also want a cos x graph here. Okay, how to do that now? So we will take x numpy dot linspace again from 1 to 10 with 100 units, and now there will be a case that y1 will be is equals to sin x np dot sin of x, and y2 is equals to np dot cos x. Okay, so I don't write plt figure size again, it will just randomly give me some figure size now, but when you are doing it for your paper, it depends upon what is your priority there. So I'll just directly plot x comma y1, and what I will do is I'll write something like this, and then I'll provide it a label is equals to sin of x. So basically the dash g will give dash lines, a straight line actually gives straight green line for sin x plot, and label, okay, so no need to write this, label will actually give it a label, you will see how. So plt dot plot x comma y2, and let's say we will do it as b, so this will be now a dotted blue line, and let's say label is equals to cos x. Okay, something happens. Okay, so blue b will give you the dotted line for cos x plot. When I'll just do plt dot show, you will see I have not given it any title or x or y label, you can just see from here only. There is one mistake, whenever you are writing labels here, you have to write one more matplotlib command to show the labels properly. Okay, so we will plot one more thing, grid, and we will also plot plt dot legend. Plt dot legend must be at the last before show. Okay, so you see here now it is showing that the green line is sin x and the blue line is cos x, actually cos x. But when I will write this plt dot legend above, you see that it's giving an error. Okay, so basically it's not, it's showing a box, but it's not giving the label. So the correct position is before plt dot show. So this is the method you can use. So there is one more thing you can use, you can see that x's are not equal. Okay, so you see that they are not starting from at the same point. Okay, so how you can do that? There is a very simple command here. You can just write plt dot axis and just give it axis a command equal. So you see it's centered now. Okay, this you can use on your priorities. So now what we can do more is, there is something also called y limit and x limit, but for that not that much difficult. We will use in Gaussian curve when we will be doing the analysis of Gaussian, maybe tomorrow or day after tomorrow. So that will help us more. Okay, so then there is a type of a plot which is known as histogram. So what we will do is, we will create a data numpy dot random dot normal. For this normal command is actually for creating a sample size for a histogram. So let's say 0 to 1 with 1000 evenly distributed things, and just we will do is plt dot hist, and now data and bins is basically how many bars we need. Bins will be is equals to, let's say either we can do auto or 30, let's say, and color, so you can define the color as, let's say, black. Okay, so when I will do plt dot plot, it might not work because we have to just do plt.show. Plt.plot works for these type of graphs. Okay, so you see we have these 30 bins. I'll use a light color, let's say light blue only. Okay, spelling mistake, light blue. So you can now see that we have this thing here. Okay, so you can see different bars here. Okay, so these are actually 30 bars. What if you can also use bin, you can use bins is equals to auto. It will automatically create some numbers of the bin. So this is how you can create a histogram. However, this is not much used, but can be used at certain time when we have a very complex graphs, like we have a graph here just like this, and we have histograms on axis. So you might have seen in some paper that there are like plots on axis also. So that's a very complex case of Matplotlib, and it's also a kind of artistic work of Matplotlib. We will try to deal in future. So now there is something that we can also make a line that can fit this normal distribution kind of thing. How to do that? For that we need to apply Gaussian method or normal distribution. For that we will be doing it in our further lectures. Okay, so then we have a scatter plot. Scatter plot is something similar to this. Let's say I take the same data here, and instead of plot I just write scatter. Okay, and rerun this. Okay, so there is an error. Okay, so why it's giving you the error? So wait a second, I'll just firstly give it a one case here. I'll use a simple graph first, and in the place of plot I'll just write scatter, and yeah, so you see it worked. Okay, so it's actually a scatter plot, a dotted plot. Okay, so this is how a scatter plot works. So we can also actually use a random scatter plot. Let's say x is equals to numpy dot random dot rand. So this is a shortcut if you don't want to just go to the whole things. Okay, so similarly I'll create it for y evenly distributed, and you see that this is a scatter plot. Okay, so what I'll do is I'll remove the savefig file, and I'll title it as scattered plot yeah, and make it as y. And okay, so I have to rerun this sine graph because it has updated. So now, yeah, okay, so then we have something called error plot. So error plot is useless to teach you right now. We will be dealing error plot with the real data set, so we will be covering that in future with the real data. Okay, so right now because with error we have to take some error values also, and then we have to take y values, and we have to design in the log. It will be more hodgepodge, so we will be using that with the real data. So right now it's I think this is sufficient. The last thing in Matplotlib that you have to learn and is very important is basically the subplots. You have seen that in astronomy papers and in any journal paper there are many subplot diagrams, so adjacent to one another. So how we can use it? So there are two methods, so we will be learning it by two different methods. So subplots. Okay, what happened? Okay, something happened. Okay, I'll just okay. So it was just a small glitch, I guess. So using first method is using plt.subplot. This method seems easy in starting, but it is a longer method. Okay, so how we will be creating it as figure size, let's say fig size is equals to, let's say now 7 cross 4, and let's say plt dot subplot, and now we have to define row, column and panel number. So let's say it's a row number, total rows will be 2 and there will be one column, and this is the first panel number. Okay, so rows, column, panel number. So in a diagram which is having 2 rows, it is the column 1 and panel number 1. So it will be actually plotting plt dot plot and x comma np dot, so I will just write here linspace 1 to 10 100. So I have defined the x value here. Now comma np dot sign x. So I have defined these things here. Now it will actually give the error because now I have written sin x here, but there is no defined x value. So x will be is equals to here only. So I'll just write x here, and now let's say I'll give it green color with this line. So now I'll define the second plot in the subplot. It will be subplot, and then it will be the second row only, second row. So there are 2 rows, first column, and this is the second panel of that diagram. So basically these are rows and column which doesn't change, the panel number will get changed. Okay, so similar diagram I'll plot here, just I'll change the sign to cos and make it blue, and when I will just do plt dot show, you will see that we have 2 different curves here. Okay, you can apply a label also. Let's say you apply the label is equals to cos x. I guess it must work, but I have not used it from the long time, so I used another method actually. That might seem difficult in starting, but that is perfect. So yeah, it worked actually here. So but it is not showing this label for the sin x. Okay, but it must not do something like this. Why it's doing that? Okay, so now we are not incorrect with the code. Actually the legend works only for the plot just before that. Okay, so if we try to do something like this, now it will work. So legend is actually considering this plot as another entity and this plot as another entity. For one legend it will just create a label for that specific plot. The plot which is before that command line will have to be assigned a different legend. So this is one of our drawback of this kind of subplot. Okay, so now we will use the different method, which is basically, so you can actually make a 4 cross 4 matrix and you can just change the numbers. Okay, so what we will do is we will use the different method now, which is method 2, that is axis method. Now using this method, what we have to do is, let's create now a 2 cross 2 matrix which will be 4 subplots actually. So 4 plots. So let's assign x is equal to np dot linspace. There is no need to assign x again and again actually, but right now because we are changing x for we are creating different plots, so we have to just get some different values again and again for x. So I am defining it right now away. So let's define it for 2 pi 0 to 2 pi for x. So np dot pi, as I told you, with 100 evenly distributed numbers. So let's say y1 is equals to np dot sin x. So I'll copy this. So I'll just change here cos, tan, and now let's say exponential function. So this will be 4, this will be 3, this will be 2. So these are all the functions. So now when we have to plot here, we have to just give it 2 parameters here, 2 variables here, figure and axis. Okay, now we have to write plt dot subplots. Here it will be subplots with s at the end. Here it was not subplot, so we have to just write subplots for the first time, which will be 2 cross 2, that is 2 cross 2 matrix. Okay, so now it will say you can also set a figure size here also, so which will be like figure dot set underscore size inches. So it is always in inches. So let's say 7,4, okay, for the subplot. And now to plot the subplot, we don't have to use plt dot plot. Okay, so we will be using axis dot plot, ax, then the square bracket 0, 0. That will be actually at the 0, 0 position in the matrix. Now you will say that in Python we learned that the indexing start from 1, 1, but there is an exception here, that in while creating this Matplotlib plots, we have to make it start just like in normal mathematics, so from 0, 0, that is ij values, okay, which is dot, and now we have to write dot plot and then x, y1, and let's assign it some color here. Color is equals to, let's say, pink. Okay, so we will write it twice. Okay, so I just run the code by chance, I'll not show you right now. So we have 0, 1, then 1, 0, then 1, 1. So I have written all ij possible values. So it is actually axis, I, j, bracket I, j. Okay, so this is the thing. So I'll change 2, 3, 4 here. I'll change this to black, green, blue. Okay, so you see here these are different kind of plots here. So why this is showing some some kind of text here, because we have not written plt.show at the end for a clean plot. So similarly you can actually give it the title and all that stuff in the similar manner, in the same manner. Just for different plot you have to just go down to the different plots and write them there. So in the same manner, however we will be doing that in future. So for now today's part is done. So if you have any query till now, you can ask. I'll stop the recording here. I'll share the problems for these kind of things today. However, I recommend first to solve the problems that I have given yesterday, because they are also very tough, I think. So if you have done those problems, you can just give a try to the new problems. But if you don't have time to solve those kind of problems, you can just go through these lecture notes. That are more than sufficient for the basic Python. So I'll end up the session here. So you can ask for the any query if you have.